Hi everyone. Today is the day 2 of learning GIS in depth. The previous video was just a glimpse of how you can input data, apply symbology and filters, and perform basic data visualization in GIS. In this video, I will have a dataset of vehicle crashes of Tempe, Arizona, with which we can extract valuable insights to improve road safety, inform urban planning decisions, and understand patterns of traffic incidents. So this is the CSV data that I have with column names of X, Y, object ID, incident ID, which you can see here, date time, which is not formatted because this does not follow any of the formatting of the ArcGIS Pro, which we are going to discuss later. And we have year, street name, cross street, and we have distance from the street, and we have junction relation if it's on, if it's related to if the accident or incident is related to junction or not. We have the count of total injuries, we have the count of total fatalities, and we have injury severity like no injury or possible injury or incapacitating injury, and we have collision manner like how the collision happened, like from rear end or from left turn or at rear end or at angle and so on. So this is the light condition. So let's see the lighting condition of the road. This is the weather condition of the road. This is the surface condition of the road. This is the unit type. Okay, so if it's a driver or a cyclist, so on. And this is the age of the driver. This is the gender, and you can see some of the values are null here. And this is the travel direction. And this is the action that they were taking, and this is the violation type like inattention, distraction, or speed too fast for conditions. Okay, this is the alcohol use, if they have influence of alcohol or not. This is the drug use. And okay, so this is for the driver. This is the age of the driver, this is the gender, this is the travel direction. So we have it for both so we have two units which are crashing against one another. So we have the data of both of the units. And also, if the driver one, driver two has drug use or alcohol use, and so on. So, and this are latitude and longitude, which are these x and y coordinates here. We are going to import this data into ArcGIS Pro. However, we have an issue with the datetime. Like this datetime is not properly formatted. So what if we split this into either date only and time only, or ArcGIS only support up to this format like YYYY, DD, and SS format, and plus 00 is really not supported by ArcGIS Pro. Also, maybe if we need to do the analysis if the accident happened in morning or evening, we need this value separately. So you can do it multiple ways. Like you can do it in the Excel. You can copy the cell. You can go to new one and you can paste it. Now you can go to data, text to columns, and you can split it by using delimiter. You can go to next. First, let's split it by space, and next split it by plus. So as you can see, we have the splitted time here, like date time here, and like day here, hour, minute, and second here, and the splitted 00. Let's finish it. Now you can see, let's rename it as date, time, and let's delete this. Let's copy this and let's paste it into date and time at the last row here. So let's match the form also. Okay, so we don't need to move around the formatting, but yeah. So you can just click the top row and press Ctrl Shift and L for the filter, or you can just go here and enable the filter. So let's see if the data are properly formatted or not, because this is very important for doing the analysis. You can see the data ranges from 0 to 2359. And okay, so let's see for some of the, like Okay, so date ranges. So we have the data from 2012 to 2024. Okay, this is the object ID, this is the incident ID, this is the street name. Let's see what kind of street do we have. This is just a visualization of glimpse of the data. So some of the data do not have the streets, or maybe they do not have the inter data, or it is a null value. So the let's search for the maximum distance that we have. Okay, up to 5377 meters or feet. We don't know the unit yet. So this is the junction relation. Let's see what type of data do we have. So some of the values do not make sense or make sense to the particular authority, but not for us. Let's say total injury, that must all be a number. Like the maximum injury at a particular section at a particular point of time was 9. Total fatalities, which mostly is maximum is 3. Injury severity, and let's see some of the sensitive data. Okay, so age is a very sensitive data. So if you can see this, so the I think the oldest person alive in the world is 116. So how can someone have the age of 117, 18, 19, 20, 21, 22? Can you see that this type of data, like 255 is to replace the null values and so on. So this kind of data are either miscalculated or have error within when they are input as data. So you can filter them out here, or let's see, let's not select all. Let's sort by largest to smallest. So this kind of data, maybe the okay. So this 255 is basically the replacement for the null value. Let's see the so for so does it make sense for people of 111 years of age to be driving, or let's see if they are driving or not. Let's see driver 1 or 2. Okay, so let's do this. Let's include 111. Okay, let's include as it is for the present, but we have to understand that this is 255 is the value that is null. Like it is not actually the age 255. The travel direction, okay, gender has some of the null values. So also let's check for the age of the driver here. Like these are the null values, or these are the error values. Okay, maybe so is this correctly formatted? Yeah, this is correctly formatted up to 2359. What about date? Yeah, it has months, and there is no abrupt formatting from 2012 to 2024. So let's save the data and let's go to the ArcGIS Pro. Or if you know the data source, like you can go to info and you can go to open file location to directly open the file location, and you can go to ArcGIS Pro. You can select the file, which is temp request data, and you can click here. You can directly drag here, and you can add data as a standalone table in the ArcGIS Pro. So you open the table and you see it. You see the data. When you click on this, maybe it doesn't allow editing. Okay, let's bring it in our data set. You do the right click. So this is a new project. So this is under the project day 1, and this is stored under the map named map. So now we create a feature class using XY table to point with the latitude and the longitude fields that we have on the data, or X and Y data. So we create points from table, XY table to point, and let's process for some while. Okay, X field is longitude and Y field is latitude. Makes us a lot of sense. We do not have the Z values here, so let it be. And we set the default coordinate system, what it is. So these were some of the values that had null at their geometries. So ArcGIS did not process those data, and it is shown as a warning. So let me close this table. So this is the data. tempe crest data XY table to point. So this is the data that we have. You can see this. This is the accident data. So if you click on any one of those data, then you get all of those attributes. So attribute and the values that we already saw in the Excel. Again, so we can again we can address the this data quality issues such as missing coordinates or incorrect attribute values can be addressed before analysis. So for this, let's say we want to find those values which had ages like 255. So we go to select by attributes, which is in map section here, and we go to where we select the age is equals to, and we give the value, or we choose the value. So I say the maximum, or use greater than, let's say 118 or so on. Let's say is greater than 118. So we want to find those values. We apply this, and these are the values that have the age greater than 118. That does not necessarily mean that the whole data is wrong. That only means the data of age can be mistakenly input or can be miscalculated or anything. So let's begin with an analysis. Let's begin to identify the problem here. So these all are the data of crashes. And the events like crashes are really random. If they cluster in specific areas, something is causing it, like bad road design or poor lighting. Maybe we can find dangerous zones to prioritize fixes, like adding traffic lights, or we can prove that a problem isn't just a bad luck but needs action. Let's say, for example, if the crashes are clustered at the if this is kind of a mall entrance, and if all the crashes are clustered around here, so it might need better crosswalks or speed bumps. So we have the data of total injuries column in our data. Search for that. Okay, we have the data of total injuries, and we can find the total injuries where it happened most. So we have already loaded the data into the, we have already imported the CSP as a point layer using XY table to point tool. And we are ensuring we have used the coordinate of WGS 84 or, and this is this shows the exact coordinates of the mouse cursor, of the tip of the mouse cursor where we're uh, moving the mouse. So let's go to the hotspot analysis first. For this, you can go to analysis, and you can go to tools, and you can just search for hotspot. Okay, so let's click on the hotspot analysis. That is ORD G. So so it is a math formula that answers other areas where crashes with injuries are unusually clustered, like hotspots are unusually sparse, like cold spots, compared to the random chance. Like you are asking it to check every crash location and see if the injuries there are higher or lower than what you'd expect if the crashes were evenly distributed or spread randomly. So let's go to the input feature class. So here you are focusing on crashes that hurt people, not just property damage. So let's select the input feature class at the table XY2 point, which you had input data. And let's say the field as total injuries. And let's set the distance as 500. And let's see what 500. Okay, so this is the distance which we are considering. It may be 500 meters or 500 feet. But for now, let's consider it to be 500 meter. And also, so for each crash, you are looking at crashes within 500 meters. And if a cluster of crashes with injuries exists in that radius, it is flagged as a hotspot. So let's run it. Okay, so let's hide the layer for now. You can click on the tick and untick button. Okay, so you can see the red areas as well as white areas. Okay, let's talk. So these are the red areas and blue areas. So let's talk about the hotspot or the red areas. Let me close this first. So these are the areas with crashes with many injuries clustered together more than a random chance. For example, there's a busy intersection with train crashes causing injuries in 500-meter radius when let's say most of the areas have only 2 to 3. So what matters is these zones need urgent fixes like traffic lights, speed bumps, or better lighting or anything. Let's go to some of the cold spot areas like this one. So cold spot areas are those areas where crashes with injuries are much fewer than expected. Like this is a quiet residential street with only one minor injury crash in 500 meters. These are the safe zones. And we study what's working here, like good road design or maybe something, and we replicate it elsewhere. So these gray areas, if you can see, are no clear pattern. So they are neither hot nor cold areas. Maybe we can omit them for our study purpose. We can select the layer and go to properties and we can rename it, or we can directly click on the text part. So let's see, let's rename it as hotspot, cold spot, light, click OK. Again, go to properties. So if you're clicking OK, you can directly go to definition query. And let's add a definition query. So this is just like you do filter in Excel. So let's, okay, let's see the table first, attribute table. So these are the values. So let's focus on the GI bin, which I will explain later. So GI bin of -3 indicates the cold spot region, like these regions, safe regions, and GI value of, of 3 or 0 to 3 indicate the hotspot region. You can right click on the GI bin fixed and do start descending. So these values, these regions are the hotspot regions. So what I want to do is I want to only include hotspot as well as cold spot region. So the value of 0 is kind of a gray region, like these regions. So I want to omit these regions for now. So I want to filter out where GIN fixed is not equals to 0. Only select the hotspot as well as cold spots. Okay, if you can see this, there are no more neutral points here. There are only hotspots as well as cold spot. That is safe intersections, safe regions or unsafe regions. So this is the table that you have. So it tries to answer some of the key questions like where should Tempe or this region invest in road safety? Like it should prioritize those hotspots. It should add traffic cameras or other safety measures. Are injuries evenly spread or some of the areas are riskier? Or does a 500-meter radius even make sense? Yes, it makes sense because it is a walkable distance about 5 to 7 minutes. If the crashes cluster within this range, it is likely due to a local cause like a dangerous stretch of a road. Now, how to interpret these results in ArcGIS Pro? Like red or hotspot means the high injuries clustered. Blue or cold spot is the low injuries clustered. So looking at the statistical significance, ArcGIS Pro will show the confidence level like 95% confidence or 99% confidence that the hotspot is real and not random. So we need to focus on the high confidence regions. And also that can be indicated by this. So these values having 3 is almost more than 99% confidence that those regions are hotspot regions. Again, the hotspot is a cluster of high frequency or high severity accidents over time. It indicates a systemic risk like poor road design or heavy traffic or blind spots. For example, if you have a busy intersection with weekly classes, so it is labeled as unsafe because the likelihood of severity of accidents is abnormally high compared to the normal. Compared to this, cold spots are a cluster of low frequency or low severity accidents over time. Accidents here are rare or random, often due to isolated factors like driver error and so on. For example, a quiet residential road with one accident in very few years. It is labeled as safe because the risk is statistically lower than the average. So let's decode the output columns from the JT's old GI hotspot analysis in simple terms. Here's what each column means using your example row. This example row, okay. Object ID is a unique ID for a point, just a row number in our input table like this one. Click on this, do the right click and go to attribute table, or click on Control and T. So this is the object ID, and this object ID is the corresponding to that same object ID. And shape is a point, like we have the geometry type for all of our crash data are in points. Next is the source ID, again likely links back to the original crash data. And we have the total injuries, so is the number of injuries for this specific crash, not the total in the neighborhood. Like this crash only, it is also from the previous data. Next is GIS score fixed 500. And let's sort it. You can double click it, it sorts into the ascending. Once you again double click it, it sorts into the descending. So G score measures how extreme the clustering is. A high positive value like 5.84 is a hotspot. A high negative value, like if you do the double click on the left side, on the left row, on the one here, you see these regions lie on the hotspot. And if you double click here, you get the descending order, ascending order, and you see these regions are cold spot. That means higher values indicate the hotspot regions. Next is p-value. P-value is the probability that the clustering isn't random. We see this the p-value or GIP fixed value. Like it's confident it's a real hotspot. So let's see. Okay, so there and these values which are less than 0.05, 0.05 are very statistically significant, whereas these points are quite not significant compared to these points. If you double click, so these points are very significant. These points having the value less than say 0.05 are significant. And next is n neighbors. So n neighbors means the number of neighbors within your 500 meters. So since we have plotted 500 meters within our 500 meter search radius, okay, this crash. So this crash particularly had this point. Okay, this crash particularly had 684 nearby crashes considering the analysis. And again, since we discussed previously, so this is the simplified hotspot class. Plus 3 is statistically significant hotspot with 99% confidence. Minus 3 is significant cold spot. 0 is not significant. Since our value is 3, it's a strong hotspot. Again, you might be wondering why does the value with 0 injuries show as a hotspot? So like this region have 0 injuries, but why does it show as a hotspot? This analysis, hotspot analysis, GT's or G analysis doesn't just look at one crash. It looks at all crashes within the 500 meter radius of that point. Even this crash had 0 injuries, the area around it might have many crashes, many crashes with injuries, making it a hotspot. So think of it as a dangerous zone around the point. Even this is not an exact spot, isn't the worst. So this is from the hotspot analysis. Now next useful analysis is the kernel density analysis. Well, both of those regions are used to highlight the critical regions. Both have some of the significant differences. Like, okay, let's do the kernel analysis first and describe. Go to analysis, go to tools, and let's go to kernel density. And click on enter. This is the kernel density. Okay, we have the feature of template crash data. Okay, let's click here. Template crash data. We just click and drag, or we can click the down arrow. Let's not use the population field, or we can use the population field of, let's say, total injuries. We want to distribute it based on the magnitude of the total injuries. Let's not. Okay, let's run it now. So we can see this. If you unhide this, if you hide this, then the points that you see are those points. Like you can see the points with the greater value are the points where most of the data are clustered here. So let's say here are 5 points clustered with 0 accidents. Hotspot won't highlight them as a hotspot, but kernel density creates kind of hotspot in the raster. It only cares about the proximity, and this value is a raster value, by the way. So since if you look at this this data, this is a point data. So you can see there is feature layer, labeling, and data. If you click on kernel ID, you can see there is a raster layer, because this value, this is a raster that we have, and it has some pixel value and it has class value. So if you do this, so you might see some of the regions that are present here. So they are, so if you don't understand it yet, so if you click on this, so these are only to, like they only create about the proximity. So if the points are near, and even if they don't have the accident, the kernel ID is just about the density. Let's say the number of points in the particular raster, but in the particular area. So if you're trying to visualize the accident intensity or identify general BG zones, we use the kernel density. If you want to find statistically proven danger zones, we use the hotspot analysis. Or if you're trying to allocate resources to area with high severity crashes, we use the hotspot analysis. Okay, so hotspot analysis focuses on the statistical significance of values like accident counts, and it ignores the areas with low values, zero accident clusters. Kernel density, on the other hand, focuses on point density, like if it, like not the values, unless you use the population field. Next is it highlights the area with many points close together, even if the point have zero accidents. Again, if we care about the significantly statistically significant clusters of high or low values, we use hotspot analysis, and we use the kernel density analysis if you want to visualize where the points are basically concentrated. So this is all about the kernel density analysis. Now let's do the date time analysis. I remember we split the data into the date and time. Let's see the main data. So this is our main data. Let's hide everything now. Let's go to template graphs data and let's close this one. We have the data of date and time. Let's use the date and time to see the date time analysis. You do the right click on the layer, go to properties, and here's the value of time. Here's the field of time. So filter layer content based on attribute values, it automatically detects the date. If it's in the format, it will show. If it's not in the format, it will show a warning error. You can either go to Excel and manage the refine the formatting, or you can do it from the using the Python command in the ArcGIS, which you're not going to do it right now because we already have it done. Let's click on apply and OK. Then you see a time layer here. You can fix the start or end, or you can provide the number of steps or step interval. Or what I can do is I can click and drag it here, and I can click on play. You can see the clusters being added on real time. You can see the time here. Or we can pause it anytime, and let's make it a small strip rather than a big one. Let's make it a small strip. Let's say of 6 months probably, roughly. Or you can directly input your values here. You can directly input the date here from like starting day in day, and you can lock either. You can lock, let's see for every 1 month, and you can lock the interval, and you can move it from the beginning. Okay, you can click it and drag it, making it a larger portion of the screen. You can just make it very large data. This is the data from 2012 January. Okay, so this is from the starting day of the month to end day of the month. You can see how the data are being distributed. Or if you think this is very slow, you can just click it down here and you can set to not 1 month but to 1 year. Let's do it again. You can see it. Let's play it again. 12, 14, 15, 16, 18, 19. Okay, so if you see it around here, let's see around 1920. Okay, you see this region have very low number of points compared to this region or compared to this region. This is particularly due to COVID-19, which restricted the travel of which decreased the travel. So this may be one of the reasons due to because for the low traffic accidents. Okay, next is a buffer. Let's go back to hotspot and cold spot. So a buffer is a zone that is drawn around a point, line, or polygon feature to analyze the proximity. For example, a 500-meter buffer around a crash hotspot means you are creating a 500-meter safety zone around it to study what's inside, like a school or road. So let's do the double click on the hotspot layer, or do the right click and click on properties. Now let's go to definition query. This time we are not going to we are going to only see the hotspot values, so it's greater than 0. Click on apply. That is GI WinFix 500. This value is greater than 0. It has to be 0, 0, 1, 2, and 3. 3 means stronger hotspot and 1 means weaker hotspot. So let's create the buffer around the hotspot. So does it work? No, it does not work with hotspot because it is the time value of the temp crash data. You can see it. Okay, or you can just disable the time for now if you don't want to visualize. No time. Right? Okay, and you disable it. So I want to see the regions. I want to create a 500 meter or 500 feet buffer around the hotspot. I want to identify, or I want to create the safety zone, and I want to see if there are any schools or roads within these safety zones or within this 500-meter zone, so that I can adjust my travel, or I can warn the pedestrians, or I can help improve the safety around the schools, because these are very sensitive places. Okay, first let's create a buffer around the hotspot. Go to analysis, tools, and let's click on buffer. Search the buffer. So we input the feature as hotspot, cold spot. And you see, we see the selected records is just one. Maybe we have selected on the 1 point. We don't want this to be of only 1 point.